Okay, so how many of you encounters this problem that something works on your machine but it doesn't work on client's machine? How many of you encounters this problem?
As this is my
Sometimes.
career was so short, but I did not actually yet
Okay,
face this problem.
so every developer once in a while face this problem, whether in job, in professional section or educational sector. When we are in university, it also happened with us that something works on our machine, but it does not work on our professor's machine. So why do we start with this meme? So let's talk about it. So welcome to today's session. Today we're going to start learning about Docker. So last day we have seen how to install Docker in any Linux server. From today, we're going to dive deep into how Docker works. Okay, so at first, everyone will have to install Docker on their machine. If you are using Windows, you have to download the Windows version. If you are using Mac, you have to download the Mac version. It's relatively easy. Just search on Google Docker download, and you can download from there Docker desktop. Nothing else. It's nothing fancy. Just go here, choose your operating system, and then download. It's relatively easy. So I'm not going to show you how to download and how to install that, because since you are watching this tutorial, I am assuming that you already know how to use computer and how to download and how to install software. So I'm not going to show you that. But one thing I'm going to say that in some machine, specifically in Windows, you might found some problem while launching Docker at the first time. It will be something like virtualization or something, etc., etc. So you have to just search Google for the solution. It is normal solution. Basically, you have to go to the BIOS and turn on virtualization. Sometimes it is an issue with Windows feature menu. So virtualization can be also turned on from Windows feature. So that's another issue, but you can easily solve that by searching on Google. Okay. So after install Docker for the first time, if we run the Docker, we have to first sign into our account. Then we are going to some say blank screen actually, like something like basically you will see a blank page here. Like if I delete this one also, I have already tested it like this. You will see something like this here, nothing fancy. So it just Docker desktop is an UI that we are going to use, but if we can do everything from command line also. So Docker desktop is not really that necessary, but we have to keep it running. See, I have kept it running in the background. So for the Windows and Linux, you have also need to keep it running in the background. Okay, so let's jump into the code. So here you can see I have a directory called Python. There is another directory for Node. I am going to uh, go into that folder later, but let's first Let's see what in the Python directory I have. I have one requirements file. It doesn't have anything, just the Flask application because I am using a Flask server. Then app.py, it's a normal Flask file that if I go to the data route, I will see this message, nothing else. It's relatively simple. So usually what would we need to do to run this Python app? First, we have to create virtual environment, then install the requirements, then run the necessary command, then it will be running on our system, right? So basically what happened is, if we want to run the same program in another machine or another server, we have to do the same thing, create an virtual environment, create install the requirement, and then run the apps. Instead, okay, not instead, in this process sometimes there can be some other issues like versions problem, OS requirement issue, etc., etc. To resolve this, we use something called Docker. And to use Docker, we need basically just one file, that is Docker file. See, we have to write it like this, Docker file. And I'm going to go in details what is written there. That's nothing fancy here. Everything is very easy. Okay. So what Docker does? Docker actually creates a virtual machine, virtual operating system. I guess you guys are familiar with VMware or virtual machine. So what VMware does or virtual machine does is you can run Linux within Windows, or you can run Windows within Mac. So that is what virtual machine does. Docker is something similar. We can run another OS with the help of Docker. Okay, so let's start from the beginning of the Docker file. Every single Docker file has to start with this line, from then an image name. This is called base image. Docker file needs to run using a base image. So this is a Docker specific command from. Then we have to give the name of the operating system. Okay, if I hover here, you can see my ID is suggesting something. Say initialize a new build stage and set the base image for subsequent instruction. That means I need to initiate an image, and the subsequent instruction or commands will be run within that image. So what is this image, or what is this operating system? Have you ever heard of an operating system called Python? No, Python is a programming language. It is not an operating system. Okay, so it's a bit confusing. If I had written here like this Ubuntu, then it will be easier for you to understand. Okay, this is an operating system. So what am I doing? I'm creating an Ubuntu based Docker. Okay, but we are not going to do that. Why? Because the file size. If I write Ubuntu like this, or I can select another versions like uh, this is actually called tag, or you can call it version. So it is actually full Ubuntu image. So you know how large is Ubuntu itself. So we are not going to do that. Instead, we are going to use something smaller. Or if I go to the Docker Hub, you can go to Docker Hub and search for images from here. So let's say I need an Python based image. I need an Ubuntu based image. So Ubuntu, this is the official Ubuntu image, hub.docker.com. You can note the URL hub.docker.com. And here you can see there are different version 20.04, 22.04, etc., etc. This is the latest version. We can also write this version number after using this command. Ubuntu colon the version number. Okay. So instead of installing the Ubuntu itself and then install Python within Ubuntu, what I have done is I have searched for Python directly. So, okay, so this is the Docker official image. What Python does is it creates pre-built operating system that has already Python installed. Let's say I have used Ubuntu here. Let's say, for example, if I use Ubuntu, Ubuntu does not have any Python installed itself. I mean, it does actually, but it does not have the required version. Let's say it has Python 2 installed, but I need actually Python 3, 3 point, let's say 3.13. So what I need to do, I had to install the Python 3 inside Ubuntu using apt install Python, something like that. So inside the Ubuntu, I need to install that, but I don't want to do that. That's why I directly search in the Docker Hub using Python, and here I can see that there are many versions, there are many pre-built versions Python has already created. So as I was saying, I need the Python 3.13. So if these are just version, you can see these are comma. I can use any name. I can write specifically bookworm here. 3.13 hyphen bookworm and bookworm. This is same because they are in same line. You see, if I write 3.13.1 hyphen bookworm or this one or this one or this one, all of these tags actually the same. Similarly, if I write any one of this, I will have the bullseye image. But since I have written bookworm, I will have the bookworm image. Then there are slim, there are alpine, then windows. There is actually pre-built images here. So for now, I have choose bookworm. So this is actually the operating system we are going to use. This bookworm operating system is already have the Python 3.13 installed. So I don't have to install that separately because it is already installed. Okay. Next is work directory. What we are doing is we are creating a directory inside the operating system and setting that work directory as setting the directory as a work directory. So it's nothing else. You can also write it like this. So the root folder will be the work directory, but I have just written like this /f. Okay. Then we are just going to copy the requirements file into the work directory. So we just write copy, then requirements file, requirements.txt, same as this. And this dot means we are going to paste this inside the work directory or app directory. You can also like something like this and uh, test.txt. So it will be copy and rename the file. But since we are not using one that we are just we want to copy as it is, we are just writing dot. We are not changing the file name. Okay. Then next is pip install requirement.txt. It is normal command. We all of have already used this command. Just we are running this command. It's okay. So first we have copied the requirements, then we have run the pip install. See, we are not actually using virtual environment here because this operating system is already going to run this application. Okay. Then what we have done is copy everything. So at first, what we have copied the only the requirements file, right? But we have other files here also. So we need to copy them as well. So we actually copied everything as it is. Copy dot dot. Copy everything as it is inside the app directory. Okay. Then there is something called expose. So what expose does is it allows us to use the application using this port. Then just cmd python app.py. This is actually command we have used to, like python app.py. Since but we have to write it as an array of string like this. We cannot write it as it is. We have to write it as a array of string. So that is actually basic Docker file. Uh, uh, Docker file actually. So at first we have to specify an base image, then set the work directory, copy requirements, install requirements, then copy other part of the code also, expose the port, and run the actual file. So why 5000? Because the app itself is running on 5000. Since the app is running on 5000, we are just exposing the port 5000. Okay, let's say our Docker file is all written, then our code is all written, everything is good. We have tested in our local machine. Now we want to run it using Docker. So there are several steps to run it. At first, we have to build the image. So there is a command here, Docker build. I'm going to explain everything. Okay. The command is start with the Docker. Okay, but first I have to go to the inside the folder. If I run this command here, it will give me an error because this command is running on the tutorial folder. But if you see in the tutorial folder, there is no Docker file. There is a Docker compose, but I am not talking about that. But there is no Docker file, so it will not work. So what I have to do is first go to the directory that have the Docker file, and inside that I can run this command. So the command start with the Docker command, then build. So because first we are building the image, then -t. This t represent tag, because we are actually we want to name the image. We can also run it like that, Docker image, then dot Docker build dot. It will work, but for our um, for the future reference, we are just going to name the image. So t means we are tagging the image. So what is our image name? Python API. I have renamed it as Python API, and then colon and latest. This is actually the version, but in Docker we called it tag. I can write it as 1.0.1. It will also work. It doesn't actually matter, but I have just written it as latest. Okay, so if I press enter, it has you see what it is doing. So initially it will take some time, but for me it didn't take any time. Why? Because I have already run this command earlier. To reduce the time, I have already run this command earlier. So what it actually does is it downloads the operating system from internet. So my PC already has this operating system. Also, one more thing, Docker file works as a layer by layer. So in Docker, every line is a layer. This 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 line is a layer, and so on. Every line is layer. And if I make change in any layer, for example, let's say I have change in the requirements.txt, like I have also installed request library, for example. So I have made a change in the requirements, right? So the next time I I build the image, you will see. You will see what happened. Okay, you can see uh, the bookworm is already in our system. See, it didn't take any long. It didn't take any second because it is already installed in our system. Then work directory, it's already cached. See, it is coming from cache. Then this found that I have made a change in the requirements.txt. So what they are doing is running the pip install command and doing everything. So if I change in any layer, it will run bottom layers also. But if it doesn't found any sense, it will not run anything. It will just use it from the cache. Now, if I run the command again, you will see how fast it is. See, it didn't take any time. But here it took more time because nothing from the copy, this part, they found that I have made some changes. So Docker need to run this command again, run pip install again, copy everything again, and actually he needs to do everything again. So it took copying took 0.3 second, installing took 44 second. But here you can see everything is cached. So since there is no sense, it doesn't have to do any more work. Okay, so I have built the image. What's next? So now I have to run the image. So to see our build images, we can run one command, docker images. Here you can see the Python API is already here. It is you can see the size. It is about 1.03 GB. So the Python API is 1.03 GB, and it is created about a minute ago. You have just seen. I have just built the image just a minute ago. Okay. Then now we need to run the image. So to run the image, there is a big command, but it's not that complex. So to run image, we are just going to write docker, then run. Then this -t, and if you can remember in earlier command, this t means tag, and now this t is not tag actually. This t represent terminal. So we can skip this t, but we are using this t because since we in the future we might have to log into the terminal. But if you are sure that we don't have to go to the operating system, I mean terminal means this is also an operating system, right? So it might happen that we need to log into the terminal of this operating system, just like we are using this terminal in our machine. We can use also log into the terminal of this system. I mean, this is actually a Linux system. We can also log into this system. To do that, we just have to write t here. Okay. Then d is mean detach mode. If we don't put d, it will block our terminal. But we don't want to block our terminal. That's why we put d. Then name hyphen name. We're just naming the image here. Actually, this container here. This is not called container. Then port. P represent port, and this is there are two ports. One is external port, another one is internal port. So internal port is what we define in the Docker file 5000, or what is running inside our machine. This is Linux machine. What is running inside this machine, and this external port is what we are going to use from our browser. Then restart. This is restart policy. We are just writing it unless stopped. Don't restart it. Then we're just going to Python API latest. If you can remember, we have already renamed it in the build stage. Python API slash colon latest. We're just using the same name. If I don't use the latest, or like 1.1. If I run that, it will throw an error because there is no version called 1.1. See, it is saying unable to find image Python 1.1 locally. So now it will search in the internet. I mean Docker Hub. But it doesn't. All Docker Hub also does not have this. Also, I need to log in a terminal. That's why it is throwing that error. But we're not going to do that. Just write the image tag name as it is. Now, if I press enter, so our image has been started. If you want to see, you can see the in the container section, you can see our image is running on 5000 port. And also I have talked about the terminal. If we click here, we can visit the terminal that in this operating system, and you can see it is running on localhost 5000. So if I want to visit the application itself, if I go to the browser and visit the route, I will get the data. This data is coming from our API. See, I have made a request and it is showing the log. If I make another request, it will show second log. If I show another request, hit another request, it will show another log. So it is actually running within the Docker. So that is basically how Docker works. Now I'm going to give you another example, but first let's try to optimize our Docker file. The first thing we're going to do is remove this operating system, because as you can see, this operating system is about 1.1 GB. There are many operating system in the Docker Hub. As you can see, there are Bookworms, Slim, Bullseye, Alpine, etc., etc., etc. But I am used to actually the Alpine image, because this is very slim image. It is very little. It is about 6 MB or 4 MB, something like that. So it will not take that much space. So instead of bookworm, I'm just going to write Alpine. You can copy it from here also, 3.13 hyphen Alpine. I can also directly write Alpine instead of specifying the version. It will also work, but I like to specify the version so it does not have any conflict. Now, one more thing, let's delete this image here, container from here, because we are changing the base operating system. So I have a question to all of you guys. I have made a change in this layer, right? So if I build the image again, what will happen? I have made a change in the first layer. What will happen now?
I think if the version, if you have already download that version, it will take small time. But if you don't install it yet, then it will take more time actually.
Okay,
The
yes.
first time.
Since I don't, first thing first, it will search for this version in our computer. If it found this version in my computer, then it doesn't have to download this version again from the internet. It will just use the existing version from my computer. So, okay, this is the first thing. Second thing is, since I made change in this line, Docker will run every second layer after this line. So if I made change, let's say in this line, Docker will not run this line, but run everything from under this. Similarly, if I made change in this line, Docker will not run anything from the above of that line. It will run everything from below the line. It- this is how layer works actually. Okay, so let's choose the Alpine image and see what happens after building it. So first thing I'm telling you is this is that I don't have this image in my machine, so it will take some time and download the operating system from the internet. So it will take some time. So in the meantime, if you guys have any more question, any more confusion, you can ask me. Okay, as I have seen that I don't have the image in my system, that's why it is downloading from the Docker Hub, rest docker.io. It is downloading the whole operating system. So the image has been down, the operating system has been downloaded. Now Docker is running every subsequent layer also, since the top layer has been changed. Okay, the build has been complete. Now let's see the size of the image, if it is reduced or not. Now it is only 60 MB. Earlier it was 1.1 GB. Now it is only 60 MB. How cool is that? So the size of the Alpine image is about 6 MB or something. Yes, Mehrab.
Okay, about the size. If our project is big, is it some effect on the size? Like if our project is big, then we should take a larger size of Dockerfile or
No, no, no,
operating system.
no. As I have said, our main operating system Alpine is about 6 megabyte. But why is it 60 megabyte? Because we have also installed requirements. We have copied our app file also. So since we have copied everything, that's why our size increased from 66 to 60 MB. So if our project itself is 1 GB, then it will be 1 GB and plus 6 MB like that. But if we use the previous image, our image size will be 2 GB. So we what we do is we try to keep it as minimal as we can. You understand?
Okay, yes. So basically, the operating system is actually just for running the command in our
Yes,
Docker size, and
yes, exactly.
based on the operating system, it can reduce the size of the uh, um, whole system or
Yes,
whole project.
yeah, exactly. So it does not actually matter if I am running uh, a small application or large application. Based on the application, the size will be increased, but the base operating system size will be the same. We try to make it as small as we can. But bear in mind, you might have the question why Alpine is only 6 MB and Bookworm that we have used earlier is 1 GB. You might have the question, right? Uh,
Yes.
sometimes when you are using Alpine image, you might have some problem that you don't face in other operating system like Bookworm, or directly if you use Ubuntu as well, you don't face that problem because the bookworm itself has some packages installed. Like when you install an operating system for, like in this Mac machine, uh,
Like some pre-built apps or pre-built
pre-built apps,
packages.
right? Yes, like you can
Yeah.
see the Find My Maps, Messages, FaceTime. These are already installed, right? I didn't install this. These are already installed. This is the same in our bookworm. Some apps are already installed,
Okay, so
and
then if
since
we face any error, then we have to manually download the packages or libraries using this Docker file.
yes, something like that or exactly like that, because sometimes our application depends on other system application. Sometimes in that case, we are just going to do install those application, like using this run apt apt update and apt install, like that. If we don't have Python installed, we can install it like this. But since we already have the Python installed, we don't have to do that. AP, APT or APK? Let me search, because I forgot actually. What Alpine use. It might use APT or APK. Okay, Alpine use APK. Okay, so in this Docker file, you see we have used 3.12 Alpine version, and we have installed another package, which is get text, right? Because this is a system application, and our application is depending on this system application. That's why we have to manually install this system application in this in our Docker file. But if we used bookworm or any large image, it might happen that this get text is already installed that system. We don't have to install, we might not have to install this separately. But since we are using a very slim version of the Linux operating system, we had to install this package separately. This is actually the concept, nothing else. Okay, so we have successfully built the image. Now we are going to run the image again using the same command, docker run. T means terminal, D means detach, then name. We're just going to name the container. Then port is 5000 is internal port, and this 5000 is external port. We can also change this external port to anything like 5001. So our internal port, and the application internally is running on the 5000 port, but externally we're going to use 5001 to access this. Then this that policy, then the actual image name and tag. If I run this, okay, it has done running. You can see it is showing in our Docker desktop. You can also see this in using terminal, Docker ps. It will also see your container. So this is our container name, as I have written here, Python API. This container ID, it is automatically generated ID. This is the image name and image tag that I have defined here. And the command is what I am running the image with here, Python app.py, the command. But I have written it as an array of string, but it is uh, exporting as a normal command. Then the port is 5001, and it is TCP port. Now the interesting thing is, if I go to 5000, it will not work. See, it will not work. but our app itself is running on 5000. See, it is exposed at 5000. The app is running on 5000, but it will not work because I have write 5001 as external port. So to access that, I need to visit 5001 port, and that way I can browse our content. Is there any question till now? Anyone?
No, I don't have any question.
Okay. Now let's say we want to uh, stop running this server, right? We can do that using Docker desktop using this icon stop, or delete this entirely using this delete button. But we can also do that using terminal. To do that, we're just going to Docker stop and the container ID or names. We can use both of them. So let's use names. We can also use the container ID here also. But since we have already mentioned name, we can also use name. So it is now stopped. If you see there, it is also, you can see it was green earlier and it is changed to start. Now, if we visit, it will not work. Okay. But our container is also still there. We can also delete this Docker, Docker, I think it is remove Docker RM. Yes, Docker RM. Then the image name again. Well, the container itself is now removed. You can see it is not here as well. The container is removed. And if I now run the docker ps command, you will see there is nothing. Earlier, there was the Python API or container. Now there is nothing. Okay, let's say I want to see the build images. So to see the build images, I have to run this command, docker images. Nothing fancy, docker images. You can see we have these many images in our system. This is the Python API, and these are the some other images also. If I want to remove any of the image, let's say I want to remove this image, then what I need to do? I need to either copy the Docker image name, but since this Docker image does not have any name, I can just copy the image ID. To remove an image, I just need to Docker RMI. So Docker RM means we can remove a container, and RMI means we are removing an image. Then paste the image ID and it will be removed from our system. But if some other container is depending on that image, then it will throw an error. But if the image is not depending on other container, then it will actually successfully remove the image from our system. So let's wait. Okay, it has been deleted. Now if I run the Docker images again, you can see there is one less image here. Earlier we had this many images. Now we have only this many images. Okay. So I have seen how to run an Python app. Is there any question on anything?
No.
Is there any question about the commands I have used in the terminal? Please response.
No.
Not any question.
Okay. Then I think we can end this tutorial.